In this lesson, we're going to solve the same differential equation as the previous video, but we're going to be using Euler's relationship or Euler's formula to do this. So, as with all solutions to differential equations, our first step solve the homogeneous. Equation. And that's in a video, first order homogeneous. You might want to look at that if you haven't. And our solution that we came up with was CE to the 3t. Okay, now we want to be able to solve this, but we're going to solve it by rewriting this as a completely new differential equation, and similar to how we did before when we solved with Euler's. So we're going to change this equation. Remember, this is a brand new equation. It's just that because we can use superposition, we can simplify things down. So we're going to have our original term cosine 2t, and we're going to add 5j e to the negative 3t sine 2t. And we can simplify this down. And this is going to be like Euler's. And we can simplify that down even more. And we can use the law of exponents to even simplify it more. And that is the equation we're going to solve. So now we need to come up with our non-homogeneous test solution. And we're going to use AE to the negative 3 plus 2j quantity t, and now we can put that into our differential equation. Now to do the derivative, the a constant just comes out, and we're going to have the derivative of e to the quantity negative 3 plus 2j t, and using the chain rule and our derivative, we're going to have minus 3 plus 2j e to negative 3 plus 2j t. So this factor, this complex number, just gets treated like any other number when you do the derivative. And minus 3a e negative 3 plus 2j quantity t Okay, now you notice that our exponentials are going to go away. We can distribute our a through. Actually, let's just leave our a out for the moment. And if we use the distributive property and everything, we can get a negative 6 plus 2j equals 5. So a is going to equal 5 divided by minus 6 plus 2j. So let's simplify that. Multiply by 1 using the complex conjugate. And that's just multiplying top and bottom by the same number. And the conjugate is just the complex number, but you change the sign of the imaginary part. And do the top. It's minus 30 minus 10j. Do the bottom. I'm going to simplify this just because we've done it so many times. It's the first multiplication of the first terms, the real parts. So that's going to be 36. And then we're going to add the coefficients of the imaginary. We're going to just multiply those two together and add those. So it's going to be plus 4. If you need to see how we got this, you can go look at the videos on imaginary numbers in the prep video area. Also check some of the other videos where I've done imaginary numbers. But this is how you get to it. So now I can simplify even more. And that's my a coefficient. Now, it's time to put this back into our homogeneous solution. I'm sorry, non-homogeneous. I just split out that exponential. There's my Eulers. The e to the negative 3t, I can just take that out to the very beginning. I don't need to worry about it. I just got to keep track of it. Now do my distributive property with these two terms. So I'm going to have minus 3/4 cosine 2t minus 3/4 j sine 2t minus j over 4 cosine 2t minus j squared over 4, because don't forget the j in front of the sign, and let's collect our real and imaginary terms. We have a negative j squared. J squared is negative 1, so that turns it into a positive. Oh, I like to do cosines first. And for our, this was the non-homogeneous to our new equation. Remember that this is the solution to the new equation I came up with. For the equation that we're looking for the solution, because it was a cosine, we're just looking for the real part. So our solution to this equation that solution is, don't forget the homogeneous, and now our non-homogeneous. The exact same solution that we got, but we did it in less than, or one page less than the other solution. So it's a little bit easier.